Let's solve this set notation problem step by step. We need to find all natural numbers that satisfy two conditions. Their square is greater than 9, and their cube is less than 130. Let's create a table to check these conditions for natural numbers starting from 1. We'll need to calculate both the square and cube of each number. Let's start with x equals 1. 1 squared is 1, which is not greater than 9. 1 cubed is 1, which is less than 130. Since 1 squared is not greater than 9, 1 is not in our set. 4x equals 2. 2 squared is 4, which is not greater than 9. 2 cubed is 8, which is less than 130. 2 is also not in our set. 4x equals 3. 3 squared is 9, which is not greater than 9. 3 cubed is 27, which is less than 130. 3 is not in our set. Now for x equals 4. 4 squared is 16, which is greater than 9. 4 cubed is 64, which is less than 130. 4 satisfies both conditions, so it's in our set. 4x equals 5. 5 squared is 25, which is greater than 9. 5 cubed is 125, which is less than 130. 5 is also in our set. Finally, let's check x equals 6. 6 squared is 36, which is greater than 9. However, 6 cubed is 216, which is greater than 130. Therefore, 6 is not in our set. Since any number larger than 6 will have a cube greater than 130, we don't need to check any more numbers. Therefore, our set in roster notation is 4, 5. These are the only natural numbers whose square is greater than 9 and whose cube is less than 130.